Hey friends, my name is Z and you're watching MakesItEasy, and welcome to a new video for IGCSE at Maths. And today we have a new video on Surds, 4 questions only for Surds. And I covered the rules and examples last video, and if you haven't watched it, just check out the description or check out my YouTube channel. But anyways, these Surds questions are from DrFrostMaths or DFM, so you can check out the PDF in the description or you can check it out in my website at www.MakesItEasy.com. And before we get into it, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And let's go into the first question. Write Surd 50 or root 50 in the form of k Surd 2, where k is an integer. So to break up Surd 50, we have to break it out into 2 different surds, like this, times this. And the numbers that go into these 2 surds, they have to be one of the numbers have to be a perfect square. Let's say 4 because 2 times 2 is 4, or like 9 because 3 times 3 is 9. And another one has to be a prime number, like the most simplified version. And both of these numbers have to times together to get 50. So the number I could think of are 25 and 2, because 25 is a perfect square, like 5 times 5 25, and 2 is a prime number. And 25 times 2 equals 50, which is what we want. So root 50 can be rewritten as 25, Surd 25, root 25 times root 2, which you can see that root 25 is just 5 times 5. That means that Surd 25 equals 5 times by root 2, which is just 5 Surd 2. And there you have the simplified version, where you have, let's change it, k is 5. That means that the final answer is k equals 5. So k equals 5, as so. And for number 2, we have root 8 can be expressed in the form of m Surd 2, where m is a positive integer. Express 8 Surd 8 in the form of m Surd 2. So it's basically like the first question, but there's already a whole number. So to solve this question, we just have to simplify this Surd 8. And the whole number that's going to be on the outside has to be times by 8. So we can just isolate 8 first to make it more simpler. So 8, let's just isolate 8. 8 Surd 8. So Surd 8 can be simplified to, as previously on here, we can use this technique. Surd 8 can be simplified into Surd 4 times Surd 2. Because Surd 4 is a perfect square and 2 is a prime number. And we know that Surd 4 is just 2 because 2 times 2 is 4. So 2 times Surd 2 is 2 Surd 2. And 2 is a whole number on the outside of the surd, and 8 is also a whole number. So you have to do 8 times 2 to get a whole number on the outside of the surd, which is 16 Surd 2. So we can see that m here and 16, they are equal because they both have a Surd 2 in the inside of the surd. Hence, it means that m equals 16. So, m equals 16. And for question 3, fully simplify Surd 27 plus Surd 3. So from our last rules and examples video, we know that we can't just add surds together without the same base in the inside of the surd. So in this case, we have 27 and 3 as a surd in the inside of the base. So we can't just add it up. However, we can add or minus surds when they have the same base inside the surd or the square root sign. So we know that root 27 is not the fullest because we can simplify into two different separate surds. And they are Surd 9 times Surd 3. Because if you combine these 2 surds, you would times the number in the inside of the surd, which gets us 9 times 3, which is 27. And consequently, Surd 9 is a perfect square because 3 times 3 is 9. So Surd 9 can be rewritten as 3 and times by Surd 3, which is the simplest form, 3 Surd 3. So let's rewrite this. Surd 27 plus Surd 3. Surd 27 can be rewritten as 3 Surd 3 plus Surd 3. And we have the same, let's just highlight this. 3 Surd 3. 27, this. So we know we have 3 Surd 3 here, both 3 Surd 3. So we can add them up together just like normal addition. So we will add like the whole number. So 3 surt 3 plus 1 surt 3, or surt 3, because 1 is not written because it's like understandable. 3 plus 1 is 4. So the final answer would be 4 surt 3, right here. So the final answer is 4 surt 3 in the fully simplified version. So question 4, fully simplified 2 surt 5 plus surt 20, which is the like the one just now. So surt 20 can be split into, let's rewrite this. Can be rewritten into surt 5 times surt 4, because 4 is a perfect square, surt 4, and surt 5 is a prime number. And also because we have surt 5 here and surt 5, we have to like match. So surt 4 can be rewritten as 2, because 2 times 2 is 4, so the square root of 4 is just 2, times by surt 5, which is just surt 5. So let's just rewrite this. 2 surt 5 plus 2 surt 20 equals 2 surt 5 plus 2 surt 5, or 2 surt 5 times 2, because they are the same values. And let's just highlight this. And when we have the same base inside the surt, as I said, we can just add the whole number up on the outside. So 2 surt 5 plus 2 surt 5, the 2 plus 2 will be 4. Therefore, it means that 2 plus 2 is 4, so the answer is 4 surt 5. So therefore is 4 surt 5. Pun intended. So 4 surt 5. So for question 5, simplify 5 surt 2 times 3 surt 2. So here we have two things going on. We have to times the whole number on the outside, and the surt, we have to do like two different things at the same time. So let's rewrite this. 5 surt 2 times 3 surt 2. So let's just write we can just times out the whole number because it's easier first. So 5 times 3 will be 15. And then we have 2 like this. And let's just color code this. 5 times 3, 15. And the surt 2 times surt 2. So we know that surt 2 times surt 2 will be equal to 2 itself, because any two like root number times together gives us a note like that without a power, because a surt, or like a root, like a square root, is essentially 1 over 2, like to the power of 1 over 2. And if you have a number like, let's say a to the power of 1 over 2 times a to the power of 1 over 2, we know that in indices the power add up when it's times. So 1 over 2 plus 1 over 2 will be 1, which just leaves us with a to the power of 1, which is just that number. So in this case, it will be 15 times 2, which means that the final answer will be 30. So the answer, 30. So for question 6, we have expand this bracket right here, giving you an answer in the form of this. So let's just rewrite the bracket like so. So to expand the bracket, we have to use the FOIL method, which is basically the first term times the first term times second term times first term, and second term times second term. So it's basically like you have to times by every term. So the first term would be 2 times 1, which is 2. The second term would be 2 times surt 3, which is 2 surt 3. The third term will be surt 3 times 1, surt 3. And the fourth term will be surt 3 times surt 3, which is just 3. So that's basically our final answer, but we have to simplify it to the fullest, because at maths we have to simplify it to the fullest for every equation or expression. So 3 plus 2 will be 5, and 2 surt 3 plus surt 3 will be 3 surt 3. So that's our final answer, 5 plus 3 surt 3. So we move on to question 7. It's basically the same. We have to expand the bracket. I find this in the form of this. So let's just rewrite this. 5 minus surt 8, 7 plus surt 2. And before we can just times it out, we have to realize that we have two different radicands, which are basically the numbers inside the surt, like the square root sign. So we have the radicand of 8 and the radicand of 2. So we have to simplify this radicand of 8 into something base 2, or like root 2, so that it's easier. So root 8 can be rewritten as root 4 times root 2, because 4 times 2 is 8. And root 4 can be rewritten as 2, because 2 times 2 is 4. So it will be root 4 times root 2, which is just 2 root 2. And 7 plus root 2. So to use the FOIL method, we have 5 times 7 for the first term. 5 times 7, 35. And in the second term, 5 times root 2. The third term, minus 2 sub 2 times 7, which is 14 sub 2. And the fourth term, minus 2 sub 2 times sub 2, which is just minus 2 times 2, because sub 2 times sub 2 is 2. So minus 2 times 2 is 4. So the final answer would be 35 minus 4, which is 31. And 5 sub 2 minus 14 sub 2, which is just minus 9 sub 2. And that's our final answer. So 31 minus 9 sub 2. And for question 8, simplify this expression or like bracket, giving an answer in the form of this. So we have this answer where you have to write it in the radicand of 18, but it doesn't matter because we can just simplify it first. We can just go about by simplifying the root 50 first. 7 plus 2 root 50. 5 minus 2 root 2. So let's see. Root 50 can be rewritten as root 25 times root 2, and root 25 is just 5. So it will be 5 times 2 on the outside, then root 2, and 5 times 2 root 2. And let's use the FOIL method to expand the bracket. 7 times 5, 35. 7 times minus 2 root 2, minus 14. Let's just rewrite this. Minus 14 root 2, and then 10 sub 2 times 5, plus 50 sub 2. And then minus 2 sub 2 times 10 sub 2 will be minus 2 times 10, which is minus 20 times 2, which is minus 40. So it will be 35 minus 40, which is minus 5. And minus 14 sub 2 plus 50 sub 2, which will be plus 36 sub 2. And notice that we have to convert this sub 2, the radicand of 2, into a radicand of 18. So let's just focus on this right here, 36 sub 2. And let's just use the long way. We can just square the 36 to become 1296. It will be this. Times 2. Times 2. And if you times them together to like become a big surd, it will be surd 2592. As so. So let's write up here. Surd 259. And we have to find a perfect square, which if times by 18 will get 2592. So in this case, you will just do like 2592 divided by 18, which will get us 144. So it will be 144 times root 18. Because 144 is a perfect square and 18 is the one that we are required to. So here, 18. So root 144 can be rewritten as 12. Right? Because 12 times 12 equals 144. So it will be 12 times root 18 or 12 sub 18. So just combine the two. The final answer would be minus 5 plus 12 sub 18. Because we have this sub 18 here, which is just this part right here. And then we have the plus 5 from here. Then we have question 9. Work out the value of surd 12 minus surd 3 squared. And before we just expand the brackets, we can actually do some simplification here to make life easier and to make math easier. So let's just rewrite it out. Surd 12 minus 3, this. So we can actually just simplify surd 12 first to become a radicand of 3. So surd 12 could become surd 4 times surd 3 minus surd 3 squared. And this will be, on top here, surd 4 is just 2. So it will be 2 surd 3 minus surd 3. And that will be much easier because we have the same radicand of like the surd. That means that we can just simplify it. So 2 surd 3 minus surd 3, just surd 3 square. So we know that if we have a surd number, the radicand, like let's say surd 3 and 3 is a radicand. If we square the surd, the answer will be just the radicand. So surd 3 squared will be just 3. or let's just write in a new color. It will just be 3, so 3 is the final answer. So 3. So for question 10, we have expand and simplify this right here. So you would normally expand it out, and we can just do the simple way of like cancelling out because we have a minus here. But in this case, we'll just work it out so that it's easier to see the whole, like visualize the whole like equation and how it works. So for this, we have 2 plus surd3 squared. We have 2 plus surd3 plus 2 plus surd3. Expand it out to become 2 times 2 is 4. 2 plus surd3 plus 2 plus surd3 will be 4 surd3. And surd3 times surd3 will be 3. So it will be 7 plus 4 surd3 for the first part. And for the second part, 2 minus surd3, it will almost be the same, but you will realize that some signs are different. So 2 times, let's just rewrite out. Delete this, and then write this again. So 2 times 3 will be 4, and 2 times minus surd3 will be minus 2 surd3, and the third term of 2 times minus surd3 will be again 2 minus 2 surd3. So minus 2 surd3 plus minus 2 surd3 will be minus 4 surd3. Minus 4 surd3. And minus root 3 times minus root 3 will cancel out the minus. Root 3 times root 3 will be 3. So it will be plus 3. So it will be 7 minus 4 surd3. So these two combined will be 1 minus 2, which is 7 plus 4 surd3 minus this. So don't forget to put a bracket around it. This bracket is quite important because you have to like times the minus and then this. So this is the minus sign and minus sign, so it'll be a plus after. So it'll be 7 plus 4 surd3 minus 7 plus 4 surd3, which will be our final answer over here, which you can see 7 and 7 they cancel out, and so because 7 minus 7 is 0, and 4 surd3 plus 4 surd3 will be 8 surd3. So the final answer is 8 surd3. So you can see how this question about squaring like brackets and the minus will affect how the outcome would be, because the whole number will be like cancelled out. So moving on, we have question 11. Given that a is a positive integer, show that this is always a multiple of 3. And an input note is that write the expression in the form of 3 and the bracket something. So we have to do some simplification in the inside and outside of the bracket. So we can start off by writing, so we know that the outside of the bracket will be only 3, so that means that we have to do something to the a. So we can rewrite surd3a as surd3 and surd-a, and bracket this surd12a plus a surd3a. So to get rid of the surd-a, we can just times surd-a into the inside like this, times it. So surd3 bracket surd12, and surd12a can be rewritten as surd12 times surd-a because the radicand, you can just times it together. So surd12 times surd-a times surd-a again because you times the surd-a from just now, plus a and surd3 surd-a as well, because surd3a can be rewritten as surd3 times surd-a times by surd-a as well. This will get us surd3 and then in the bracket surd-a times surd-a will be a, so it will be a surd12 plus surd-a times surd-a will be a, and the a here times the a here will get an a square. So it will be a square plus 3, as so. So we have to do something with the surd12 and surd3. So let's bring it up here. So we can simplify the surd12 to become with a radicand of 3. So it will be surd4 times surd3 because surd4 is a perfect square, and 4 times 3 is 12. So surd4 will be 2, so it will be 2a3. It's the same, this and this. So this plus a square surd3. So we can notice that we have a common factor of surd3. We can pull it out into surd3. cert 3, and then 2a plus a squared. So we notice that when we have cert 3 times cert 3, it will just become 3. So let's write our final answer. Cert 3 times cert 3 will be 3, and then 2a, it will just remain. And that's how we can prove that it's always a multiple of 3. And to show that your proof is done, it will be write Q, E, D, which basically means what needs to be proved has already been shown. And this always means that it's a multiple of 3 because we have a 3 on the outside here. So whatever you have, like let's say if a is at 1000, 2 times 1000 plus 1000 squared, whatever times by 3, it will still be a multiple of 3 because 3 will always be a multiple of 3. So let's just write our final answer of 3 and 2a plus a squared. So question 12, we have a plus cert 8 squared can be rewritten as a form of like c plus d cert 2, where a, c, and d are integers. So find in terms of a an expression for c and an expression for d. So we can rewrite, we can expand the bracket. A cert 8, a plus cert 8 squared. It will be a plus cert 8, a plus cert 8. So if you expand the bracket, it will be a squared, a plus 2a cert 8 plus 8. So we can rewrite it to regroup the cert and non-cert. It will be a squared plus 8 plus 2a cert 8. And you know that we have this expression right here, which is equal to this. So we can do this equal c plus d cert 2. So you know that this is not our final form, I just realized. So we can just simplify this into our final form, like 2a cert 8. The cert 8 can be split into cert 4 times cert 2, and that cert 4 is 2 basically. So it'll be 2 on the outside, 4a times cert 2. So just have a moment, and I'll rub this out in the inside. So it'll be plus 4a cert 2. Just rub this. So now we have two different expression. So find in terms of a an expression for c, which we already have right here, and find an expression for d in terms of a, which we already have. So our final answer would be, hence c equals a squared plus 8 and d equals 4a, and that's our final answer. And moving on to question 13, we have this right here, e minus 2 cert 3 squared equals f minus 20 cert 3, while e and f are integers. Find the value of e and the value of f. So let's just go about this by expanding the bracket first. E minus 2 cert 3 squared, which is just this. So let's expand the bracket. E times e will be e squared. Minus 2 cert 3 times e will be minus 2e cert 3, and another minus 2e cert 3 will be minus 4e cert 3. I'm just simplifying the second and third at the same time. And minus 2 cert 3 plus, times minus 2 cert 3 will be minus 2 times minus 2, 4. 4 times cert 3 times cert 3, which is 4 times 3, which is 12. Plus 12. So this simplifies into e squared plus 12 minus 4 e cert 3, and let's group the cert and non-cert. So we know that we know that f equals f is a non-cert, so the f must equal to this non-cert right here. And we know that minus 20 must equal to the cert because it's attached with cert 3. So the minus 20 must be equal to minus 4e. So let's just write it out. E squared plus 12 equals f, because it's like you're comparing the coefficient and you're matching them up, and minus 20 equals minus 4e. So we can just simply like finding what e is by dividing both. So cancelling the square, the negative, and 20 divided by 4 will be 5. So e is 5. E is 5. So input it into this equation. 5 times 5 squared will be 25, and 25 plus 12 will be f. So f will be 37. So our final answer is E equals 5, F equals 37. And that's it. And then question 14. A equals Surd 7 plus Surd C, and B equals Surd 63 plus Surd D, where C and D are positive integers. Given that C, D is 1 to 9, find in the simplest form the ratio of A and B. So that we have this clue right here, C and D, if C ratio D. So we know that in this ratio right here, this colon, it basically means divide. So whatever like C to D, it will just equal to C over D. So like we can rewrite as C over D equals 1 over 9. So then we have this expression of 9C equals D. So we can just substitute this into the equation. So for A we already have C, so just remain it there. But for B we have a D. So for B we can just rewrite it as root 63 plus root 9C, which is equal to root 63 plus root 9 and root C, just to simplify it, and this plus 3 root C. So we can actually simplify it further, because root 63 is also equal to 9 times 7 plus 3 Surd C. So actually B can be rewritten as 3 Surd 7 plus 3 Surd C. That's an important thing to note. So we're trying to find what AB is, right? That's right on the top. A to B will be equal to A divided by B, basically, because as we said, AB will be equal to A over B. So A over B, we can just divide those. So it will be root 7 on the top A plus root C, and B is just number 2 right here. 7 plus 3 root C. And you can almost cancel out, but there's a 3 over here, so just factorize the 3 out of the bottom. Plus root C, 3 root 7 plus root C. Cancel, you become 1 over 3. So we know that A over B equals 1 over 3. And to rewrite it into the ratio form, A to the B will be equal to 1 over 3. And that's our final answer. So A and B will be 1 to 3. The ratio A to B 1 to 3. So for question 15, we have rationalized the denominator of 12 over Surd 3. So to rationalize any fraction, you just times the top and the bottom by the denominator. In this case, the denominator is Surd 3. So you have to times, you have to times the top by Surd 3 as well, and the bottom by Surd 3. So the top will just remain, and the bottom Surd 3 times Surd 3 will be 3, and you have to factorize it to 1 and 4, because 12 over 3 is equal to 4. So the final answer is 4 Surd 3. 4 Surd 3. In question 16, rationalize the denominator. You give me an answer in this form. So we can see that, let's just rewrite this, 1 over 8 Surd 8. So we can just actually pull out a constant of 1 over 8, so that it's easier to see. 8, 1 over this. So you can see it's the same form because I just pulled out this, so that it's a times. So I can rewrite this, 1 over 8. And I can just rationalize the right hand side over here, which is just Surd 8 over Surd 8 times Surd 8, right here. And this will be equal to 1 over 8 times Surd 8 over 8, right? So let's just rewrite it here. 1 over 8 times Surd 8 over 8. But actually, let's just rewrite this top Surd 8 over here into a Surd 2, like a radicand of 2, because we need Surd 2 on the top. So Surd 8 can be rewritten as Surd 4 times Surd 2, right? Because 4 times 2 is 8. So Surd 4 is also 2. So it will be 2 times Surd 2, 2 Surd 2, this. So when times 2 fractions together, you can like cross simplify. So it will be, you have a 2 here and an 8, and they both have a common factor of 2. So you can cancel this 2 out, and simplify this 8 to 4. So it will be 1 over 4 times surd 2 over 8, which is equal to our final answer of surd 2 divided by 32. So that's our final answer. So P is an integer, which is 32 over 32, like so. So for 17, we have rationalized this, which is like quite simple and straightforward, like just now. So 1 plus surd 2 over surd 2. If the times the bottom and the top by surd 2, surd 2, 1 plus surd 2, and surd 2, surd 2. So we have to times the top by this so that we can like get rid of the surd 2. It'll be surd 2 plus 2 and the 2 at the bottom. And I can't seem to be able to simplify this further, so this will be our final answer. So this final answer, surd 2 plus 2 over 2. So for question 18, we have write 3 plus surd 2 over 5 plus surd 8 in the form of this. So it's basically rationalizing the denominator as well. And in this case, it's something plus something. So to get rid of the something, we have to make sure that it's a difference of 2 squares. So we have to times the denominator of 5 plus surd 8, that thing times by 5 minus surd 8, so that it becomes a difference of 2 square, and there won't be like a second and third term where it's a surd. So it will be 3 plus surd 2 and 5 minus surd 8. 5 plus surd 8, 5 minus surd 8. And to explain again the reason why we need a minus over here is because that if it's a plus, if this were to be a plus, this, and this, after you times it together, there will be a term where you have to do 5 times 8, surd 8 plus 5 times surd 8, which will be another surd, like something, surd 8, which will further create another surd, which we don't want because we're trying to get rid of the surd. So when we do it as minus, there won't be any surd because the plus will cancel out the minus. So on the top we have 3 plus surd 2, and in bracket 5 minus surd 8, it will be 11 minus surd 2, and the bottom will be 17. Just to simplify it, because I tapped into my calculator just to save some time. But you can just work all of these out because in math you have to write all your working out. So don't do it like me. So that will basically be our final answer of this. So to reiterate, this form right here, that means that A will be 11, and B will be minus 1, and 17 will be 17, and root 2 will be root 2. So it will be 11 minus root 2 divided by 17. And for question 19, work out this in its simplest form. So let's just rewrite this. 5 plus surd 3, 5 minus surd 3, and surd 22. And we can rewrite this by timesing up the top, like to open the bracket, so that we can just simplify it with the bottom. So we can just rewrite this as 22 over surd 22 after timesing out everything. And to rationalize the denominator, we can times both top and bottom by surd 22. Surd 22 and surd 22, surd 22. It will be 22 surd 22 over 22. So we can just divide this by the same. So the final answer will be surd 22. Because 22 over 22 will be 1. So it will be just surd 22, which will be our final answer. So surd 22. And then question 20, fully simplify this. It looks a bit complicated, but we can just break it down. We can just solve the denominator first. So we're gonna ignore the top first. Just ignore this first. So the bottom will be 1 over surd 3 plus surd 3. This can be rewritten as 1 over surd 3 plus, to make this a fraction, we can times both sides by surd 3. Surd 3 over surd 3, so that we can add those fractions up together to become 1 over surd 3 plus 3 over surd 3, which is 4 over surd 3, as so. So let's combine these two fractions together. It will be 4 over surd 3. which we can actually just flip the bottom fraction up, like reciprocal it, because this thing is basically 4 divided by this, which will be times, if you flip it, like reciprocal it, for this. And then you can just basically simplify the 4, like cancel out the 4, so that it will be 1 times surd3, which is just surd3. And that's our final answer of surd3. And let's move on to question 21. Given that c is a prime number, rationalize the denominator. So we have to times the top and the bottom by root c as well. So the top will be root c 3 minus root c, and bottom root c and root c. So the top, oh, I missed a c. So wait, here, 3c minus root c. So we know that in indices, when we have a power times a power, we have to add the power up. So 3c times root c will be 3c to the power of 3 over 2. Because a square root is to the power of 1 over 2, and 1 over 2 plus 1 will be 3 over 2. And then will be c over here, and then another c. So we have to rationalize the denominator and make it into the most simplest answer. So we can actually just cancel the c out here by factorizing out. So I could just, let's just factorize all of this out. And we have to make this into the most simplest answer. So I'm going to factorize c out of the top. And I could also just take this root c out, but it will be like hard to see because I'll just write the whole thing out so that it's more easier to see and visualize. So it will be c 3 root c minus 1 in c. And you can cancel the c out to get our final answer of 3 surd c minus 1, which we won't be able to like quite easily spot if we don't write everything out. So the final answer will be 3 surd c minus 1. So moving on to question 22, we have this. Work out the exact area of, in cm cube, the shaded area. So we have this right here. So we know that AD equals BD equals root 2 over 2. So this will also be root 2 over 2. So to work out the shaded area, we have to do the big triangle, the area of the big triangle. The area of big minus the area of small. So the area of big will be half root 2 square, like so, minus the area of small, which is just half CD, which is root 3 over 3, and then AD, which is the base of the small triangle, which is root 2 over 2. And I'll quickly simplify it so that we don't like extend this video too long. So the answer will be 1 over 4 minus root 6 over 12. So we could actually just simplify this further by timesing the 4, like this thing here, to base 12 or denominator 12, but it's easy to just leave it here. So this will be our final answer right here, 1 over 4 minus root 6 over 12. Then question 23, we have this right angle triangle. The length of the base is 2 surd 3 and the hypotenuse is 6. Find the area of A. And we can use a trigonometry way where we can find this angle and then use the triangle formula of half AB sine C, but it will be too advanced for this surds, so we'll just do it using Pythagoras Theorem. So we have A right here, let's just set it as A. It will be A squared plus 2 surd 3 square equals 6 square, because A squared plus B squared equals C squared. So it will be A squared plus 12 equals 36. And let's find A by doing A squared equals 24. And A will be surd 24, which will be 2 root 6. And of course, if you square, it will be plus minus, but there won't be a minus length because it will be impossible. So it's just 2 root 6. So that's A. So to find the triangle A, we have to times the A by 2 surd 3 to become and half that to get the area. So the area is half base and height, which is base and height, which will be half 12 surt 2, and we can simplify the 2 and the 12, 6 to be 6 surt 2. So this is our final answer, and we can see that k equals 6. So k equals 6. And then we have question 24. It shows a right angle triangle over here, and find the value of k. So when we know that we have a right angle triangle, we have to use Pythagoras Theorem. So it will be ab squared plus bc squared equals ac squared. So in this case, let's just substitute some numbers. So it will be k squared plus 3 plus root 5 squared equals surt 3 plus surt 15 squared. And to go about solving this equation, you have to just expand this bracket and expand this bracket and just minus out together to get k squared equals something. And let's just save some time to write it right here. K squared equals 4. And k is just quite simple, the square root of 4, which will be 2 centimeter. So it will be k equals 2 cm. And lastly, for the last question, we have question 25. The cylinder has a radius of this, find the height, and then total surface area, and this, find the exact value of h, giving an answer in this. So we're going to know the surface area formula for cylinder, which will be 2 pi r squared plus 2 pi r h. And the way I remember this is that this will be the area of two circle number 1 in the top and bottom, and 2 pi rh is just the curved surface area. So we can substitute some values in. It will be 2 pi 4 root 3 squared plus 2 pi 4 root 3 h, which h will be what we were trying to find. So this will all equal to 56 pi root 6. So we can just simplify this. We can just factor out some values. It will be 2 pi and then 4 surt 3 this, and then the other bracket will be another 4 surt 3 plus h right here equals 56 pi and this. And then we can divide both sides by this right here to get rid of this on the left hand side. So it will be 4 surt 3 plus h equals 56 pi root 6 over 2 pi, and with the 4 root, actually let's just simplify this. 2 pi times 4 root 3, we can just times the 2 pi by 4, so it will be 8 pi root 3. And we can simplify this right here to become 4 root 3 plus h equals 7 root 6 over root 3. Let's rewrite this. So 4 root 3 plus h equals 7 root 6 over root 3. And we can simplify the root 6 over root 3, and we can rewrite this to 4 surt 3 plus h. And then we can split this. We can split it into half basically. And on the right hand side it will be surt 6 over surt 3. And using the surt rule, it will be surt 6 over 3 or surt 2. So we know that the right hand side will be equal to 7 surt 2. So it will be 7 surt 2. And therefore, h, let's just use a new color, h would be 7 surt 2 minus 4 surt 3. And that's our final answer. H equals 7 surt 2 minus 4 surt 3. And that's it. And that is for this long video for surds for questions only. And I hope you all found it insightful and useful. And if you did, please leave a like and subscribe and ring the notification bell so that you don't miss out on any future videos. And if you have any comments or constructive criticisms about my lessons or my website, just drop them off in the comment section and I'll reply to them as quick as possible. And just show me any comments or emails if you have any questions related to maths and any topics or questions about indices or surds. And check out my Instagram in the description for more daily content, and check out my website in the description, or you can type it out in your browser at www.makesiteasy.com. And I hope you all find it useful and helpful, and I'll see you all in the next video, which will be rules and examples for logarithms. And until then, stay safe and happy learning.